Hi, today I'm going to explain you and describe how the k-and-go preemption function in the VBA project is deployed, and also give you background on some of the requirements and concepts used in this example. The example can be found in the Vcenter Event Broker Appliance GitHub repository in the examples folder under knative go k-and-go preemption. The function itself has all the details of how the function is configured and some background on preemption. But in order to dig deeper into this concept, if you're not familiar with it, let's talk about the requirements and background systems that are involved here. At the core of this example, we're going to use a prototype that is called vSphere Preemption. I built this prototype to add or explore capabilities such as preemption to the vSphere environment. But you might ask, what is preemption? If you have heard about AWS Spot instances or Google Cloud preemptible virtual machines, you might already be familiar with that concept. In a nutshell, preemption allows a cloud provider or infrastructure provider to offer virtual machines that can be powered off or terminated at any point in time. Now, this doesn't really sound useful, does it? Well, you might have workloads which are not really critical, for example, or are built with the premise of being terminated at any point in time, such as in environments where I perform chaos engineering, or you have a distributed system, which is kind of built in a way that it's capable of running on such instances. Now, another use case is to offer cheap compute, for example, to do batch processing or some analytics use cases that are supposed to happen at the minimal fraction of cost. And it doesn't really matter if you need to restart the job there. So these spot and preemptible instances are gaining wide adoption in the cloud providers. But unfortunately, so far in vSphere, we don't have this feature. Now, vSphere Preemption is a prototype that explores for our user base whether that is a capability our communities would also like to adopt and use. So vSphere Preemption, the prototype built, in this case, uses a workflow engine. Because when you preempt a virtual machine, there's a couple of steps involved that need to be performed in a reliable way. And in order to do that, I'm using a project called Temporal. Temporal has a workflow engine, which is based from Uber, and it offers some nice capabilities to define workflows in a programming language, and also gives very strong reliability guarantees to make sure that workflows are reliably executed. You can read more about the concept of preemption and why it is useful compared to, say, for example, VM reservations in the prototype description of this example. Let's go ahead and deploy the prototype backend before we can deploy the actual function. All steps are described here in this workflow README description, so I'm going to skip over them a little bit because you can read them offline if needed. So the requirements to deploy the prototype backend are: you need the Kubernetes environment, which you might already have if you run the VBA project. You need the temporal workflow engine installed, for example, deployed via Helm on this Kubernetes environment, which I already have done in my environment. And then you need a VMware vCenter environment and security account to connect and perform certain operations, such as powering off the virtual machines. And then you need an actor, an external component, which triggers the actual workflow. In this case, this will be the k-and-go preemption function, which we will deploy in a bit. So let's cover the deployment process. First of all, the vCenter settings. vCenter, your environment needs to have a tag because we identified the virtual machines which are supposed to be powered off based on a tag. In this case, I call my tag preemptible, but this is configurable. And then based on the tag and the actual event, which comes in as an alarm from the function triggering this workflow, we will determine whether we need to soft power off or hard power off the virtual machine. Also, in order to make this traceable, all the steps that are performed in vCenter, we are using a custom attribute on the virtual machine that is powered off, and we will give more information as part of this custom attribute value, which is a JSON string that you can read and understand who powered off this virtual machine based on which event and so on. I'm going to show you that in the demo. In order to create this custom attribute and the categories, I have already done that in my vSphere environment, but you can also easily do this on the command line using govc, the govc command client, or in the vCenter UI. This is done in the menu and then tags and custom attributes. And here you already see that I have a tag created called preemptable and a category called quality of service. And the custom attribute is also there. You can see that here, com.vmware workflows vSphere.preemption. Now, this is not configurable, so you're supposed to create this custom attribute as the name indicates here. For the tag, you can choose the tag name. Now, I have deployed my temporal backend workflow system, but I haven't configured it yet. So let's do this before to show and explain you the steps that are involved here. So I'm going to jump over to my terminal. And here you see that I have a Kubernetes environment with all the components that are involved in the VBA project. For example, the Knative environment, the event router, and a couple of functions just to show that events are already in the system. In the default namespace, I have deployed the temporal test Helm chart, which you can find in the description. And I'm just using the standard deployment. I haven't done any modifications to the deployment there. So let's go ahead and configure temporal for our settings. In order to do that, first we need to exec into the admin tools part to create a namespace in temporal. Now that we are in the pod, we can create the namespace. The namespace is created. If we go back and check our temporal settings, you can see that now we have a vSphere Preemption namespace in our temporal web UI. I have a port forwarding set up for temporal, so I can access this from my local machine. Now back to the README. Next, we need to deploy the worker. We need to create a namespace in Kubernetes where we want to deploy the temporal worker, which hosts our workflow and all the logic that is involved to configure the preemption. I have already created this namespace in my Kubernetes environment, and I have also already created a secret which contains the vCenter credentials that the worker uses to perform these operations, such as reading virtual machines and powering off virtual machines. Do not use an administrator account, but create a custom role or service that the worker will use with the requirement that this role has privileges to read virtual machines and tags, and then also power off the virtual machines. Next, we need to deploy the worker agent. And for that, there's already a YAML file which we can use, but we need to do some modifications there. Let's do that. Okay, I'm execing out of my pod again. And now I'm going to curl the release from GitHub, and I'm going to open the release file with my editor. The worker uses and is configured with environment variables in order to understand where it can reach the temporal backend, which temporal namespace, task queue, and so on are being used. So let's fill this data in. In the README, the individual variables are explained and also some of the values. Since I'm using the Helm chart from temporal, I can copy and paste this value because this is based on the Helm chart. In your case, this has to match, if you have a custom temporal setup, this has to match where the front-end server of temporal is deployed. If this is deployed in Kubernetes, say in a different namespace, it would be the name of the front end, then the namespace, service cluster local, and this port, unless you have changed the port. The temporal namespace is not the namespace is not a Kubernetes namespace, but a namespace in temporal. And that's the one that we just created in the temporal admin pod. So we are going to set this to vSphere Preemption. The task queue is a custom name that you can give, and I'm just suggesting using the same name here because this is used for internal processes of the worker and temporal. Next is vCenter Insecure. Because this is a custom vCenter with a custom certificate, I need to enable insecure connections because this is a self-signed certificate. Otherwise, leave this to false. Next is filling in the vCenter URL so that the worker knows where it needs to connect to. In this case, this is my URL from vCenter. I'm going to fill it in. Do make sure that you don't have trailing slashes because that would lead to an error. I'm letting debug to on, so you see more logs in the output. And then all the other ones are fine, so we don't need to change them. Let's deploy our worker. This is also covered here in the manifest, and you can just copy this one. This will deploy the worker in the VMware Preemption namespace. We can check for logs, and I'm using here the Stern tool, which is nice because it has a nice way of figuring out which pod and which logs to extract across namespaces if needed. Stern gives me all the logs, and currently it says that the worker has started, and it's just waiting for input. Because we didn't deploy the function yet, the worker has no work to do. All right, that's it. We already deployed the worker and the backend. Now we are ready to deploy the actual function which triggers this workflow. Head back to the K&Go preemption example and jump to the deploy step. There's a couple of steps which are already familiar, like creating a vSphere tag. We already have done this, so we can skip this for now. Next, we want to trigger the function based on an alarm, a vSphere alarm. And what the alarm will do, it will, depending on the threshold, like from green to yellow or yellow to red or vice versa, it will determine whether it will trigger the workflow or stop the workflow for preemption. And this is useful because you don't want to keep preempting virtual machines if your alarm is back in a normal threshold. In this case, I'm going to create, or I have created an alarm which is triggered and raised when the cluster CPU usage is above 80%. When this threshold is hit, the function will be triggered, and it will trigger the workflow to find virtual machines that can be powered off. Let me head back to my hosts and clusters and show you where the alarm is configured. Here on my cluster, on the alarm definitions, you can see that I have created my alarm. It's currently disabled, just so it doesn't trigger while I'm describing the steps here. Okay, now that we have the alarm, let's cover the next step. If you want to create an event when a virtual machine is powered off or preempted by this workflow, you can create something called a sync binding that is injected into this function when it's called. And this way, the function will know that it's supposed to send or create an event when preemption is kicked off. And this can be useful, for example, if you run a workflow preemption and you want to send the result to Slack. Because preemption is not a vSphere native concept, there's no native vSphere event for preemption yet. And that's why this option allows you to configure a target like a sync binding where the function will instruct the workflow to send an event after the workflow has run. We want that, so let's deploy the sync binding. Let me go out of this console and go in right here. The sync binding is created and it will inject the broker, the VMware broker, into all of the functions that have a specific label. Check out the source code if you want to know more about the sync binding. Next, we need to configure the function. Open the function YAML file. And there you will find a couple of environment variables which already look familiar, that we have changed already in the worker, but now we need to change them in the function, which triggers the workflow. So let's fill in the workflow temporal URL again. This is the default that we are using. The namespace and the queue, those have to match the deployment that you did for the worker, and we are using vSphere Preemption here. Next one is the tag. The tag identifies the virtual machines which are supposed to be preempted if the alarm threshold is crossed. In this case, the tag is called preemptible. And now we also need to define what the actual alarm is that the function will react to. In vSphere, when alarms are raised, this is a generic event. There's no alarm-specific events that you will see for a specific alarm. What that means is that your function will be triggered on all the alarms, all alarm status changed events. But we'd only want to trigger preemption on a specific alarm, which is the cluster CPU above 80%. So the function is configured to throw away all other alarms or basically ignore them and only trigger the workflow if this vSphere alarm name value is matched. And that's why it's important to configure that here. And then lastly, we also have a debug. So we're going to see more output for the function. Let's deploy the function now. We can use Stern again to check for the logs. And then here in the user container, you see that the function is starting to listen. Right now, there's no activity because the alarm is disabled, so we don't see anything right now. Okay, that concludes the function deployment. Now let's see this all in action. In order to do that, let's enable the alarm. I'm going to split my screen here to show you the events that are happening here in vSphere and also the events that are flowing into the system. I'm using Socket here, which is the events endpoint in the VMware Appliance, where you can see all the events flowing through the system. I'm going to refresh that here just to start from scratch. And you already see alarm status changed events coming in. And in this case, the cluster CPU went from gray to green, which is the initial state of an alarm when it's powered, when it's created or enabled. After some time, you will see that the alarm will raise. I have artificially configured this cluster CPU above 80% to actually hit right away in 2%, just so my demo triggers the alarm. So there's no activity in this cluster. And you see there are 3 powered on VMs. One is a production VM. This one doesn't have a tag. And there's 2 test VMs, which have the tag. Now you can already see that the hosts are entering alarm critical state. And the workflow is already triggering because the VMs are powered off. You can see that here on the right. You can also check the status of the workflow, which is already triggered by the function, and it's currently running. In the history view, in the compact view, you actually see what happened in temporal. If you are not familiar with the temporal UI, let me quickly explain what happened. So first, the workflow sent was signaled, meaning the function triggered the workflow. Then there's a specific set of activities being carried out. For example, the workflow tries to find the preemptible VMs by looking for VMs that have this tag preemptible. Meanwhile, we got more signals from the function because it was triggered multiple times, depending on the number of hosts here. What we don't want is that the function is involved concurrently or multiple times while it's still running the other workflow. This logic is baked into the worker, where the worker would not trigger another preemption within a 1-minute threshold. So these signals actually were ignored and dropped. It was still working on the first signal. So the next activity it was powering up the virtual machines, and then it set an annotation, and then it sent a preempted event. Let's check for the annotation. Here in the virtual machine that was powered off, you see that the custom attribute, that is basically the annotation, was set. It's hard to read here in the vSphere UI, but you can read it with govc. govc fields info using the field name for the specific virtual machine gives you the detail. And I'm piping this into JQ just so the output is easier to read. So the annotation carries information that this virtual machine was preempted based on the tag preemptible. It was a forced shutdown because the alert state was red. Criticality was high. And then you have more details on the actual event, which triggered it, the workflow ID, and so on. This is useful for inspection. And the annotation will be updated on every workflow run if this virtual machine actually is preempted. For example, if someone powers this VM on again and the workflow is triggered again, then the annotation will be updated. You can also see that prod VM was not touched because it doesn't have the tag. In this case, the preemptible tag is only assigned to test VM and test VM 1 and 2. Now, in our events viewer, we can also search for the new event that was created as part of this workflow run. The event is called VM preempted event and is generated by the workflow worker when it successfully executed the workflow. In this case, you will see similar information like in the annotation, and you also see the virtual machines that have been powered off. What you can do now is you can create or use the vSphere at vbar Slack function to trigger off this specific event and send this one to Slack so that an administrator is notified that a preemption has run. So let me go back to the cluster and disable the alarm. Once I disable it, you see that the status is cleared from all the hosts. When I'm enabling this again, the status will go for the alert from gray to green again. And what it's supposed to happen is that the function will actually stop the current workflow, which is still running. Because this workflow will continue to run for 24 hours, but it's not going to do anything unless it's triggered by the function. And the function has logic to stop any running workflow if the threshold is decreasing. And in this case, because I disabled and re-enabled the alarm, the function actually noticed a decrease in the threshold for a moment, and so it will stop the workflow. And you can see that here in completed. If there's an error in the workflow being run, you will actually notice that the status will indicate that. And you can look at the history of this workflow and figure out where things happened. For example, I can click here and then you see the input and the result of this actual activity, what happened. All right. You can see on the left that the alert is triggering again, and it has spawned a new workflow, which continues to be running until the function is disabling the workflow. This is a completely event-driven workflow from vSphere into vbar, triggering a function, which calls into a workflow that is being executed, and then also creating an event when it terminated. This concludes our demo. I hope you enjoyed it. Please try out the vSphere Preemption prototype and give us feedback. Thanks for listening.